everyone, welcome to another new video from Guidance Education channel. In this video, I am going to discuss two laws, Avogadro law and Dalton's atomic theory. These two laws do not come under laws of chemical combination, as I have already said in the previous video. Perhaps you are already familiar with these two laws, but in this video, we are going to see some more details about the topic. Many have the misconception that Avogadro number, which we represent as Na, which gives the number of particles in 1 mole of a substance, was calculated and proposed by Avogadro himself. We shall see the truth behind it. After finishing Avogadro's law, we will pass on to Dalton's law. We will see the various postulates of Dalton's atomic theory and see which of them resemble laws of chemical combination and which law of chemical combination, and also which postulate was later on disproved. We will also see the contribution of the Indian sage Maharshi Kanad and the Greek philosopher Democritus in this connection. Such information will help in competitive exams. Therefore, this video will be of great use to you. So, watch the video completely without skipping. And if you find the video useful, like the video, share the video and leave your comments in the comment box below. I have given details of this video in the description box below. Do not forget to go through that. If you have not yet subscribed my channel, please subscribe now and also press the bell button near it so that you get intimated as soon as videos are posted. Thank you very much. We will first take up Avogadro's law. What does it state? Equal volumes of all gases at same conditions of temperature and pressure contain the same number of molecules. He identified the term molecule. The law was published in 1811, and at that time not much data was available on mole, atomic mass, standards, etc. Now we talk about standard temperature and pressure. Such things were not known at that time. It was at that time that he proposed this law. His finding was published in Journal de Physique. But at that time, that law was not very much appreciated or accepted. We should say that he was much ahead of his time. The importance of the law could be understood only after about 50 years, when in 1860 another scientist, Stanislao Cannizzaro, emphasized the importance of Avogadro's finding in an international conference on chemistry. Let us try to understand Avogadro's law in detail. He says equal volumes of all gases. For example, oxygen, hydrogen, nitrogen, carbon dioxide, water vapor or any other gas. Equal volumes of any gas at same conditions of temperature and pressure contains the same number of molecules. That is what he said. I have made a diagrammatic representation here. 3 smaller boxes of equal volume and 1 box of bigger volume, which is double the volume of the smaller boxes. And if these boxes contain gases at same temperature and pressure, and if the small boxes contain 5 molecules, the big box being double the size will contain 10 molecules. Let us suppose the gases considered here are hydrogen, oxygen and water vapor. Gay-Lussac's law says that when gases react or are produced in a reaction, they bear a simple ratio by their volume. We considered a reaction between hydrogen and oxygen giving rise to water vapor. The balanced chemical equation for that reaction is 2H2 gas plus O2 gas gives 2H2O gas, because water is in the form of vapor. Gay-Lussac said that 2 volumes of hydrogen react with 1 volume of oxygen to produce 2 volumes of water vapor. The ratio is 2:1:2 by volume. Avogadro said that under the same conditions of temperature and pressure, equal volumes of gases will contain the same number of particles. So hydrogen is shown separately and their volumes are represented as same, and it contains 5 molecules each. Oxygen has the same volume as 1 volume of hydrogen, so it also contains 5 molecules of oxygen and 10 molecules of water vapor. Avogadro's law can be considered as similar to Gay-Lussac's law in essence. Gay-Lussac spoke about volumes, whereas Avogadro spoke about number of particles. 2 volumes of hydrogen is shown as 5 plus 5, 10 molecules of hydrogen reacting with 5 molecules of oxygen, giving rise to 2 volumes of water vapor containing 10 molecules. So the ratio by number of molecules becomes 10:5:10, which can be simplified as 2:1:2. So in essence, both are same. So Avogadro's law gives more insight into Gay-Lussac's law of gaseous volume. Coming back to Avogadro number, another scientist, Johann Joseph Loschmidt, in 1865 calculated the number of particles and gave it as Loschmidt number. He used a different unit, that is number of ideal gas particles in 1 cubic meter at 0 degrees Celsius and 1 atmosphere pressure. That was the unit that he used. Later on, in 1909, Jean-Baptiste Perrin calculated the number and gave that number not in his name but in the name of Avogadro. That number is known as Avogadro number or Avogadro constant, which we represent as Na. What was the unit that he used? Number of particles present in 1 mole of a substance. And we know that number is equal to 6.022 into 10 raised to 23 particles in 1 mole. For gases, it should be at STP. So, Avogadro number was not coined by Avogadro. Avogadro number was coined by Jean-Baptiste Perrin. These details will help you in competitive exams. I hope these points are clear. Now let us discuss Dalton's law of atomic theory. It was proposed in 1808. You have already learnt these portions in your lower classes. This portion is important. We will see the various postulates under Dalton's law of atomic theory. Matter consists of indivisible atoms. All atoms of a given element have identical properties, that is similar properties, including mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve reorganization of atoms. Atoms are neither created nor destroyed in a chemical reaction. Some of the postulates have striking similarity with a few laws of chemical combination. The last statement that atoms can neither be created nor destroyed resemble the first law of chemical combination, namely matter can neither be created nor destroyed in a chemical reaction. This statement, compounds are formed when atoms of different elements combine in a fixed ratio, resembles law of definite proportion. It has been cited that the first statement that matter consists of indivisible atoms, that is, it suggests that atoms are indivisible. This statement has been disproved because now we know that atoms can be split into subatomic particles like electron, proton, neutron, etc. The concept that matter is made up of tiny particles dates back to 600 BC when the ancient Indian philosopher Acharya Kanad suggested that matter is made up of tiny particles called Paramanu. Paramanu means atom. His real name was Kashyapan, that is Maharshi Kashyapan. People called him Kanad. In Sanskrit, Kan means small or tiny. Since he was working with tiny particles, people called him Kanad. Okay. The concept that matter is made up of indivisible particles dates back to the time of Democritus, Greek philosopher. He lived between 460 and 370 BC. I hope these points are clear. We will meet in the next video. Thank you very much.